Hello, everyone. I just wanted to do a quick video describing how to do your signature assignment. So the signature assignment is designed to really test your knowledge of some basic geometry, the trigonometry that we learned, and most importantly, how to add vectors together. So I created this little problem where we have to find the displacement of a robotic vacuum cleaner. So basically we have a 15-foot by 12-foot room, right, that needs to be cleaned. And you have this vacuum cleaner that starts in the southwest side of the room. So let me show you the diagram here. So it starts in the bottom here, this corner of the room. You can think of the center, we're basically finding the displacement of the center of the vacuum cleaner. Right, so these, remember, the displacements are vectors. And you can think of it as the center starting at 0, 0. So if this is your coordinate system, so this is like X, Y, or I, J, right? So that's going to be 0, 0, the beginning, like right when it starts. And then what it's going to do is, well, first of all, I should mention that the diameter of the vacuum cleaner is 1.2 feet, right? So that means the radius is 0.6 feet, right? So that's going to be important. So basically, the robot starts moving at an average speed of 1.5 feet per second at an angle of 20 degrees with respect to the x-axis until it encounters the east wall. So let me show you that on the diagram here. So, right, it rotates positive 20 degrees, right, from the positive x-axis, and it's going to move in this direction at that speed, 1.5 feet per second, until the edge of the vacuum hits the wall here, which means that the center of the vacuum will be it'll be one radius, right, away from the wall, it'll be 0.6 feet away from the wall. Then it rotates, in this case, it rotates counterclockwise by 114 degrees. So let me go back to the description here. So it rotates by 114 degrees counterclockwise and then travels at an average speed of 1.5 feet per second again, so it's the same speed, for 3.5 seconds until it hits a piece of furniture. Okay, then the robot rotates 136 degrees counterclockwise and travels at an average speed, same speed, 1.5 feet per second, until it encounters the south wall. Finally, the robot rotates 150 degrees clockwise and travels at an average speed of 1.5 feet per second for 6 seconds, and then comes to a complete stop. Okay, so let me go back to the picture here. So it starts off, it rotates by 20 degrees, travels at that constant speed of 1.5 feet per second until it hits the east wall. Then it rotates by 114 degrees, travels at that constant speed for a certain time, right, until it hits a piece of furniture here. Then it rotates counterclockwise by a certain amount, travels a certain distance till it hits the bottom wall here. Then it rotates clockwise by a certain amount until it ends up in its final position. And I actually drew the final position. So this is like the net displacement. If I add up the D1, so this is like the first leg, right, of the route. This is like your first displacement, D1, then D2, then D3, and then D4. You're going to end up with D net. So I'm kind of like helping you by giving you at least a picture of the answer, like where it should end up. It should end up right here. So in terms of the questions, let me go over the questions, what you have to do. So again, as I have said, I drew the first two displacements for you, as well as the net displacement, which is really just the sum of all the displacements. So the net displacement is D1 plus D2 plus D3 plus D4. That's ultimately what we're trying to find, is the net displacement here. So what I want you to do first is, based on the information that you're given above, I want you to sketch D3 and D4. Remember, D1 and D2 are already done for you. I want you to sketch D3 and D4. One way of doing this, at least checking yourselves, is if you print out that picture And actually, when you go to the printer to print this out, let me click on it right now. Make sure you click on actual size, because then it'll come out correctly. So I have it set up so that basically 1 centimeter is exactly 1 foot, right? In the problem itself, we're talking in feet, but in the picture, 1 centimeter equal 1 foot. So you could check this by measuring the length of the room here. And because it's 15 feet and 1 centimeter is 1 foot, you should find that this measurement is exactly 15 centimeters when you print it out. And this will be good because then later you can check these magnitudes and make sure that the lengths are correct, like what you actually got for each length here. Okay, so that's probably important to do. Print it out, make sure it's actual size, and then you want to sketch. So D1 and D2 are done for you. You want to sketch D3 and D4, knowing that you have to end up right at that final position. Okay, next part. So for each part of the path, I want you to find the individual displacements. So D1, D2, D3, D4, and I want them in component form, right? So using like I hat and J hat. So like D1 should equal the X component of D1 I hat plus the Y component of D1 J hat. And I give you a hint, right? To find D1X, to find the X component of D1, we know that this is starting, go back to the picture here. We know that this is at 0, 0 right here, right? This is 15 feet. We know that the radius of this, since the diameter is 1.2 feet, the radius is 0.6 feet. So this distance from here to here, right? If you project this down, you'll have the X component. That must be 15, but then I have to subtract a 0.6 and a 0.6 here. And that's going to be the X component of D1, right? So you're getting that just from geometry. Then since we know this angle, you can get the Y component here by using trigonometry. Okay, so you can get the X component, just basic geometry, and you can get the Y component, D1Y, by using trig, now that you know the X component and you know this angle here. All right, so it kind of gets you started here. And then D2, I also give you a hint. So we know that the robot is traveling at this constant speed of 1.50 feet per second. And for that leg, for D2, it travels for 3.5 seconds. So if you multiply those together, that's got to be the magnitude of D2, right? That's got to be the length, the magnitude of D2, which is in this case 5.25 feet. So this length should be 5.25. Actually, if you were to measure it, you're going to get 5.25 centimeters. Now, how do you find the X and Y components? Well, knowing this angle here and knowing that this angle is 20 degrees, right? You could find the reference angle, and then you could figure out the components. You could figure out it's got to have an X component like this and a Y component that goes upward, right? The X component would be negative, the Y component would be positive. So you can figure out those components using it. Once you know the magnitude, right, which is the hypotenuse, you can figure out the two components. And so on and so forth. And then it rotates again. So then you're going to have like D3. You can figure out those components. And it rotates again clockwise now. And then it goes up to, so D4 is from here to here, to the finish point. And you can figure out those components. All right, so you want to figure out the components of each of those vectors and write them in component form in terms with I hat and J hat. Okay, once you have that, then I want you to find the net displacement. But that's where you just add the vectors together, right? So you add the I hats together, add the J hats together, and that'll give you D net. Okay, and this will be in component form, right? It'll be in terms of I hat and J hat. Once you have that, you can convert it into what it's called polar form, right? Where you have the magnitude and direction of the vector. Well, if you have the components, right? So you're going to have D net X and D net Y, right? Because it's written in terms of I hat and J hat. You have the two components, X and Y components. Then you can figure out the magnitude and direction, right? We've talked about that in class, how to convert vectors in component form to find their magnitude, basically using Pythagorean theorem, and then to find the direction using inverse tangent. Okay, so I want you to do that. And then finally, because this is a signature assignment, part of the assignment is to just write a brief reflection, you know, a paragraph or so, several sentences on what you learned during this assignment, okay? And then you will be given instructions how to also submit this as part of your e-portfolio. Okay, that's all done on Brightspace. And I'll post a link. Someone's created a video on this on how to actually set it up so that it gets tracked as part of your e-portfolio. So what I want you guys to do for me in terms of submitting this is I just want a single PDF document. So it's up to you how you want to do it. You could probably use you could do like a Word document at first, or maybe Google Docs. And if you don't want to do all your work on the computer, you could, like all your equations, you could write them out neatly on a piece of paper as long as it's done neatly, and then take a picture of it and then paste that picture into your document. Okay, that would be fine. Maybe when you print this out and you draw, so remember the first part is to draw D3 and D4, maybe you can like do a screenshot or again, take a picture of it and include that, make sure you include that into your document. And of course, the last part, E, has to be typed out, right? So that has to be written in the document. And then at the end, you're going to convert the entire document into one PDF file. So I just want you to submit one PDF file, okay? So this will all be done under activities assignments on Brightspace. So there's an assignment for this. And then that'll be it. So this is actually going to be worth 10% of your final exam. Okay, so it is important. In each of these questions here, there's basically 5 questions, right? A through E. They're each going to be 2 points, basically. You can think of it. So I'll grade this assignment out of 10 points. Okay, so I mean, if you understand how to add vectors, then you should do fine with this particular assignment, and hopefully you'll have some fun with it. Great, thanks.